In last lecture, I explained how to solve homogeneous equation of the first degree in x and y and give some example on it. Now, in this lecture, non-homogeneous equation of the first degree in x and y, I explain how to solve it and give example. So, if you know how to solve homogeneous equation of the first degree in x and y, then we can easily solve the non-homogeneous equation of the first degree in x and y. Because if you given the non-homogeneous equation of the first degree in x and y, we have to first convert it into the homogeneous equation and solving the method of solution of homogeneous equation of the first degree in x and y. So consider the method to solving it. The non-homogeneous equation of the first degree in x and y is of the form dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. Suppose this is equation number 1, which is reduced to a homogeneous form by substituting x is equal to x dash plus h and y equal to y dash plus k, where h and k are constant. So substituting x is equal to x dash plus h and y equal to y dash plus k. So if you're taking the derivative of this, we get dx is equal to dx dash and dy equal to derivative of this dy dash. So now putting this value of dx is equal to dx dash and dy equal to dy dash as well as x and value of y in equation 1, we get, therefore equation 1 becomes dy dash by dx dash is equal to a into x dash plus h plus b into y dash plus k plus c divided by a dash into x dash plus h plus b dash into y dash plus k plus c dash. Now multiply a to the bracket, b to this bracket, also a dash to this bracket and b dash to this bracket. We get a x dash plus b y dash plus ah plus bk plus c divided by ax dash a, a dash x dash plus b dash y dash plus a dash h plus b dash k plus c dash, equation number 2. Now putting ah plus bk equal to 0 and a dash h plus b dash k plus c dash is equal to 0. Putting for finding the value of h and k. A dash h plus b dash k plus c dash is equal to 0. Now putting this value in equation 2, then it becomes, then equation 2 becomes we get dy dash by dx dash is equal to ax dash plus by dash divided by a dash x dash plus b dash y dash. Equation number 3. Now, which is a homogeneous in x dash and y dash and therefore solvable by the method of equations homogeneous in x and y that explained in last lecture. So, if equation 3, this equation 3 has a solution. After solving this, we get the solution. If equation 3 has its solution, f of x dash y dash is equal to 0. Solution of this equation 3. If we get this, then the solution of equation 1 is, so we have to equation 1 is this, dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. So here we are to putting the in place of x this and y is equal to y dash plus k. So now we'll substitute the value of x dash and y dash, that is back substitution. We get f of x minus h y minus k is equal to 0. Since we have substituting the value of here x dash plus h is x and y is equal to y dash plus k. Now this method fails when this method fails, ratio of a and b is equal to a ratio of a dash and b dash. Then what happen? Then value of h and k will not be finite. That is h and k being infinite or indeterminate. So suppose a by a dash is equal to b by b dash, we consider 1 upon m. Then from this equation we get value of a dash is equal to am and value of b dash is equal to bm. Therefore equation 1 can be written as substitute the value of a dash and b dash in equation 1. So here we have to substitute the value. We get dy by dx is equal to ax plus by plus c divided by, now substituting the value, ax plus by plus c dash. Now taking m common to this 2, we get ax plus by plus c divided by m into ax plus by plus c dash, equation number 4. On putting Now here we have to putting ax plus by, ax plus by is equal to v. So now taking the derivative of this with respect to x, we get dv by dx is equal to a plus b into dy by dx. So now divided by b to the equation, we get 1 upon b dv by dx is equal to a by b plus dy by dx. So taking this value to this side, we get dy by dx is equal to 1 upon b dv by dx minus a upon b. So we get this equation. Now putting the value of v and dy by dx in equation 4, we get, so putting the value of this v and dy by dx here, we get 1 upon b dv by dx minus a upon b is equal to, now here we get the v plus c divided by mv plus c dash. So it implies multiply equation to the b, we get dv by dx minus a is equal to b into v plus c divided by mv plus c dash. Now it implies we get dv by dx is equal to a plus b into v plus c by mv plus c dash. So we have to take minus a to the right side, we get plus, and this term as it is here. Now applying the method of variable separable. Now applying the method of variable separable. So after applying the method of variable separable, we get the solution. Now consider the example of a non-homogeneous equation of the first degree in x and y. Solve 3y minus 7x plus 7 dx plus 7y minus 3x plus 3 dy equal to 0. So solution of this, the given equation can be written as 3y minus 7x plus 7 dx is equal to minus 7y minus 3x plus 3 dy. From this we get the dy by dx is equal to 3y minus 7x plus 7 divided by minus 7y plus 3x minus 3, equation number 1. Now, this is a non-homogeneous equation of the first degree in x and y. So, we have to putting x is equal to x dash plus h and y equal to y dash plus k by our method, where h and k are constant. Then equation 1 becomes dy dash by dx dash is equal to, putting the value of y and x here, 3 y dash plus k minus 7 x dash plus h plus 7 divided by minus 7 y dash plus k plus 3 x dash plus h minus 3. So now multiply to 3 to this bracket, also minus 7 to the bracket, and similarly on the denominator we get 3y dash minus 7x dash plus 3k minus 7h plus 7 divided by minus 7y dash plus 3x dash minus 7y dash minus 7k, we have to first multiply this, minus 7k plus 3h minus 3, equation number 2. For finding the value of h and k, we have to putting three k minus 7h plus 7 is equal to 0. Suppose this is equation number A, and minus 7k plus 3h minus 3 is equal to 0, equation number B. Solving these equations for h and k, we get value of h is equal to and value of k is equal to. Which value you have to get here? So by method of simultaneous solution of equation, we get the value of h and k. So here I have solved this simultaneous solution of equations. So we have to multiply equation A by 3. We get 9k minus 21h plus 21 is equal to 0. Now multiply B by 7. We get minus 49k plus 21h minus 21 is equal to 0. So solving this term cancel. So we get minus 40k is equal to 0. From that we get the value of k is equal to 0. Now putting this value of k in equation A. Therefore equation A implies, after putting k is equal to 0, we get minus 7h plus 7 is equal to 0. So therefore we get the value of h is 1. So thus we get the value of h is 1 and value of k is 0. Therefore equation 2 becomes, what is equation number 2? This equation number 2, here we have to putting the h is equal to 1 and k is equal to 0. Similarly here we get dy dash by dx dash is equal to 3y dash minus 7x dash divided by minus 7y dash plus 3x dash. So this is equation number 3. This is a homogeneous in x dash and y dash and therefore solvable by method of equation homogeneous in x dash and y dash. So in that method we have to putting, therefore here now putting y dash is equal to vx dash, equation number 4. We obtain, so first of all taking the derivative of this with respect to x dash, we get dy dash by dx dash is equal to v plus x dash into dv by dx dash. So equation number 5. Now from equation 3 and 5 we get, from equation 3 and 5 we get, now substituting dy dash by dx dash by this value and this value as it is, so we get v plus x dash dv by dx dash is equal to 3y dash minus 7x dash divided by minus 7y dash plus 3x dash. Now from equation 4 we get, substituting the value of y dash as vx dash here. So now from equation 4 we get v plus x dash dv by dx dash as it is, that is equal to 3vx dash minus 7x dash divided by minus 7vx dash plus 3x dash. Taking x dash common, we get 3v minus 7 divided by x dash into minus 7v plus 3. Now x dash is cancelled. We get it implies, now here we are taking the v to the right hand side, we get x dash dv by dx is equal to 3v minus 7 divided by minus 7v plus 3. Now here we get the minus v. Now therefore x dash dv by dx dash is equal to, now simplify this, we get 3v minus 7 minus minus plus 7v square minus 3v divided by this minus 7v plus 3. So minus 3v to plus 3v gets cancelled. We get here 7v square minus 7 divided by 3 minus 7v. So taking the 7 common, we get 7 into v square minus 1 divided by 3 minus 7v. Now we have to separate the variables. So we get 3 minus 7v divided by v square minus 1 dv is equal to 7 into dx dash by x dash. Now this value is integrable, but it is not exact integrable. So it simplify to integrate. So therefore we get 3 minus 7v divided by v square minus 1 means v minus 1 into v plus 1 dv is equal to 7 dx dash by x dash. This is the case of non-repeated factors only in the denominator. So solve this as we have. I solve this here. Consider 3 minus 7v divided by v minus 1 into v plus 1. So can write as a divided by v minus 1 plus b divided by v plus 1. So therefore 3 minus 7v divided by v minus 1 into v plus 1 is equal to a into v plus 1 plus b into v minus 1 divided by v minus 1 into v plus 1. Now here is an equal sign, also the denominator is same, so therefore numerator must be the same. So therefore we get 3 minus 7v is equal to a into v plus 1 plus b into v minus 1. Now if we putting the v is equal to minus 1, here we get this value is 0. So we get the value of b. We get 10 is equal to minus 2b. From that we get the value of b is equal to minus 5. And putting here again v equal to plus 1, we get this value is 0. So we get the value of a. So we get minus 4 is equal to 2a. from that value of a is equal to -2. So substitute this value here, we get this equation is -2 v minus 1 plus -5 divided by v plus 1 dv is equal to 7 into dx dash by x dash. Now this is written as 7 dx dash by x dash plus 2v minus 1 dv plus 5 into 5 divided by v plus 1 dv is equal to 0. These two value we are taking the right hand side. Now integrating, we get, after integration we get the values are, this is a dx dash by x dash, so value of this is the log x dash, value of this is a log v minus 1, and value this is log of v plus 1 into 5. Here we have to multiply by 2. So we get therefore 7 log of x dash plus 2 log of v minus 1 plus 5 log of v plus 1 is equal to integrating constant log c. So using the result, that is integration of f dash x divided by f of x dx is equal to log f of x. So this result using to find the integration of these three terms. So again use the rules of logarithm, we get log of x dash raised to 7 into v minus 1 square into v plus 1 raised to 5 is equal to log c. Taking anti-log of both sides, we get x dash raised to 7 into v minus 1 square into v plus 1 raised to 5 is equal to c. Now by equation number 4, what is equation number 4 is here, this equation number 4, we are to putting y dash is equal to vx dash. So therefore value of v is y dash divided by x dash. So substitute the value of v from this equation, we get x dash into y dash divided by x dash minus 1 bracket square into y dash by x dash plus 1 raised to 5 equal to c by equation 4. Putting v equal to y dash by x dash. So therefore we get x dash raised to 7 y dash minus x dash divided by x dash square into y dash plus x dash raised to x dash raised to 5 is equal to c. So therefore x dash raised to 7 into y dash minus x dash square divided by x dash square into y dash plus x dash raised to 5 divided by x dash raised to 5 equal to c. Now here we have x dash square into x dash raised to 5. We get x dash raised to 7. So cancel these terms, x dash raised to 7 to the x dash raised to 7. We get y dash minus x dash square into y dash plus x dash raised to 5 equal to c. Now putting the value of y dash and x dash in y and x, since our original equation in x and y. So this is our original equation we are given in the x and y. So we must be the solution in the form of x and y. So substituting this value here, we get y minus x minus 1 bracket raised to bracket square into y plus x minus 1 raised to 5 is equal to c. Since the reason is that x, we have to substituting x is equal to x dash plus h, and from that we get the value of x dash is x minus h, and that is equal to value of h is 1, so x minus 1. So substituting the x dash in place of x minus 1, and y we have to substituting the y dash plus k, but value of k is 0, so y equal to y dash we get. So substituting in place of y dash as a y. So therefore we get y minus x plus 1 square into y plus x minus 1 raised to 5 equal to c, which is a required solution. Which is a required solution. So this is a solution of the given non-homogeneous equation of the first degree in x and y. On the next lecture, we have to consider more example on non-homogeneous equation of the first degree in x and y.